to week 3 of our C++ track. In this video, we'll be talking about references. Let's start our discussion with an example. Let's say we've got two variables, a and b. We want to swap the values of a and b. A should end up with the value b started with, and vice versa. How might we do that? If we assign the value of b directly to a, we'll have lost the original value of a. Instead, we can throw one of our values into a new temporary variable and use it to help us swap the values around. Cool! We've got a way to swap two variables. I'm sure this is something we'll want to do pretty regularly, so let's wrap it up in a function. So here's our swap function. It takes two doubles and runs our little swap routine. Only, it doesn't work at all. The problem is that our parameter values x and y are not the same variables as a and b back in the main method. When we pass variables into functions like this, we're making copies of the original values. Thus, when we change the value of x in our swap function, the value of a back in main doesn't change. What we need is some way to tell our computer that x should actually be the same variable as a. And that's exactly what a reference is. When we declare a variable as a reference, it becomes an alias for another variable. Any operations we do on our reference are applied to the original variable. References make things like our swap function possible. To declare a variable as a reference, we just need to add an ampersand to the type of the variable. Doing that to our x and y variables in swap is all it takes to get our swap function doing exactly what we want it to do. These parameters are now references to the variables in main, so when we change their values, that change is reflected back in the original variables. Besides allowing us to create aliases to other variables, references also allow us to write more performant code by avoiding unnecessary copies. Let's look at an example to see how. Here I've created a class that prints out a message every time a new object is created, destroyed, or copied. In our main method, we have a loop that iterates through a vector of these objects. Looking at the output, we see a section of object creations that happen when our vector is initialized. At the end, we see a block of destructions when our vector is cleaned up. In between those, we can see that each iteration of our loop creates a copy of the object, runs the loop body, and then destroys the copy. At best, this is a performance penalty, because we don't actually need copies here. At worst, this breaks our code if the objects we're iterating over can't be copied. Now let's make our element variable in the loop a reference by adding an ampersand to the declaration. We can see in the output that our copies have disappeared. The reference now directly points at the objects in the vector. This leads us to a best practice. Use constant references for read-only loops over containers. We can extend this to some guidelines for function parameters as well. A non-reference type is best when your function needs its own copy of the object that it can change without affecting the original object. A reference is best when we need to modify the object the caller gives us, and a constant reference is best when we just need to read from an object without modifying it. References pop up a lot in C++ code. There are a lot of details and nuances you'll learn as you get more comfortable with C++, but those are beyond the scope of this beginner lesson. The key idea you'll want to get familiar with is that we can have variables that redirect us to other underlying objects. We'll be building on this idea later.